What's up, you guys? In this video, we're going to be talking about rational exponents. So all that rational means, rational just means like a fraction. So like 1/2, that is a rational number. 2/3, that is a rational number. And then exponents is something in the exponent. So what we're going to talk about first is just how we can rewrite things. So like what I mean is the square root of x, remember that is the same thing times itself twice. That is like saying the same thing as x to the 1/2 power. Likewise, if we have the cube root of x, that is x to the 1/3 power. I promise that's a 3. That's a 3. Fourth root of x would be x to the 1/4 power, x to the 1/5 power, right? So on and so forth. Sixth root of x is x to the 1/6 power. Seventh root of x is x to the 1/7 power. It's equivalent expressions. So they mean the same exact thing. So down here, getting a little bit more technical, notice on the inside of here, these are all x to the first powers. They don't have an exponent, so they're assumed to be to the first power. But if we don't have something to the first power, all we do, we'll notice all of these are 1 over. So for this one, if I have the cube root of x squared, I'm going to rewrite that as x to the 2/3 power. So notice the number inside went to the top. What I'm dividing by is the whatever root I'm taking. So here I have the fourth root of x squared, which would be the same thing as x to the 2/4, which is actually the same thing as the square root of x. They're both the same thing there. Here I would have x to the 5/8 power. This would be x to the 7/12 power. Well, that's kind of how that works. So you'll see more something like this. Let me zoom in. Get closer. Bigger. Yes. A little bit more. A little bit more. Yes. Okay. All right. So you'll see simplify. And we have 8 to the 2/3. So we know we can rewrite our powers. We don't have to every time because sometimes it's just going to simplify nicely. So what I mean by that is like 8, this number we know is 2 to the 3rd. It's 2 times 2 times 2. So if I rewrite 8 as 2 to the 3rd and I keep that exponent on the outside, what happens, don't forget with fractions, if we have them in this order, we multiply, and with exponents, if we have them in this order, we multiply. Fractions, we multiply straight across. Well, 3 divided by 3 makes 1. So what I am left with here is 2 to the 2nd, which we know is just 4. So our answer in this case is just 4. So get another one. You're going to have to remember some exponent rules from Algebra 1 again. But 32, the lowest that I can write that, let's think, 2 to the 3rd was 8, so 2 to the 4th is 16, so 2 to the 5th is 32. So what I can do is I can write this as 1 over 2 to the 5th to the 3/5 power. Keep our exponent out there. Well, don't forget if we have a fraction and I want to make it all be the same base, I can make this have a base of 2 if I make the exponent negative, such that I can mess with this a little bit easier. I'll still keep that power of 3/5 on the outside. So now the cool thing is that 5 divided by 5 makes 1. So I have 2 to the -3 left. So this is all 2 to the -3. 2 to the -3 is the same thing as 1 over 8. This is the answer I would be looking for. So 2 to the -3, remember negative exponents, makes that a fraction. So this would be like 1 over 2 to the 3rd. 2 to the 3rd is 2 times 2 times 2, which would be 8. All right, moving on. Same idea, except it's just a little bit uglier, but it's okay. It's no big deal. This 1/4, it can distribute. So even on this one, we could have distributed it to the bottom. We would have gotten straight to here. Sorry, I was off the paper. On this one, we could have distributed the 3/5 to the 1 and the 3/5 to the 2, such that we would have gotten straight there. So that may be even smarter. So let's do it on this one. I'll show you how that works. So 16, I know is 2 to the 4th, 81 is 3 to the fourth. So now if this is all 1/4 power on the outside, what happens is this 1/4 is applying to that 2 to the fourth as well as the 3 to the fourth. So it's going to distribute into both of those things. Well, 4 divided by 4 makes 1. So I have 2 to the first over, again, 4 divided by 4 is 1. I don't have any number up there, so this is just 2 over 3, so 2/3. Oh yeah. All right. So when we start adding variables into this, it's going to work the exact same way. So we have n to the fourth, and then I have in the exponent 3/2. Well, if we look at this, it's like 4 over 1, it's just multiplying the exponents. 4 divided by 2 is 2, so I have 2 times 3, so this is just n to the sixth. And that's it. All right, same idea, except now we have a number with our blah, 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 variable. That's what those things are called, they're variables. So 64, we don't have to go all the way to 2 to the fifth, 2 to the sixth. If you want, we can make this 8 squared, m to the fourth, 3 over 2. So the reason I made it 8 squared instead of 2 to the sixth was because I noticed this fraction right here has a denominator of 2. So I know that 2 divided by 2 will make that 1 times 3, and then 4 divided by 2 would make this 2. So now I'm multiplying, so essentially what's happening is I have 8 to the second times 3 over 2, and m to the fourth times 3 over 2. So I said the 2's divide here, so that's just 8 to the third. 8 to the third is a big number. 8 times 6 is 40, so 480 plus 32, so that should be 512, so 512. Now m to the fourth, so I have 4 divided by 2 is 2, times 3 is 6, so 512 m to the sixth. I don't expect you to be able to do 8 to the third in your head. You would have a calculator, or you can even just do it the long way. You can do 8 times 8 is 64, and then times 8. You have 4 times 8 is 32, so 2, 3, 6 times 8 is 48, plus 3 is 51. Hey-o, it's the same number. Remember, you can multiply like that, just like you did in like middle school and elementary school and all that good stuff. Still applicable. Words, I can't say words. Like my counters? Yes. Oh, so pretty. I had them installed this summer. But I built my cabinets. I did that. That was super fun. I put in skylights. Yeah, did it. Did it. I'm a real boy. All right, so we have 81. 81, I know, is 9 squared. It is also 3 to the fourth and a to the eighth. So I'm going to go ahead and distribute this 1/3. So 1/3 and a to the 8 times 1/3. So now these are not nice and pretty. But what happens here is just like what we were talking about up here. If we have like x to the 5/8, well, then that's x to the fifth and the 8th root of it. So here, where are we? There we are. This would be 3 to the 4/3, a to the 8/3. Right, and just like we were talking about in our last section, when we have kind of roots of things, we take out however many things we can. So if I have 4 3's and I'm taking out groups of 3, I will have a 3 on the outside. It'll be a cube root because I'm dividing by 3. I will have a 3 on the inside. With the a to the 8th, I can take out 2 sets of a. 8 divided by 3 is 2 2/3, so my remainder is 2. So I'd have 3a squared cube root of 3a squared. That would be our final solution. If you want to see this one worked out a little bit differently, this is the cube root of 3 to the fourth, a to the 8th. So since I have 4 3s, I can take out 3 of them, and I'm still left with 1 on the inside. Since I have 8 A's, I can take out 2 sets or 2 groups of 3. So that's the 2 groups of 3. And I'm left with 2 still on the inside. So you get the same answer either way you want to do this. All right, as always, please, please, please come talk to me. Ask me lots of questions. Love you guys, and I will see you soon. If not right now. I'm looking at you right now. I can see you. Bye-bye.